Morning, everyone, and welcome. Today's training webinar is on energy storage systems in harsh environments. My name is Nathan Heston, and I'm a trainer with Energy Solutions, Briggs and Stratton. Today, we're going to be covering battery energy storage systems in harsh environments. This is a NABCEP certified training, so if you are here for the NABCEP credits, please do stay till the end of the presentation. And at the end, I'll present my email, and you can email me how you would like your name printed on your NABCEP certificate, and I'll get those emailed to you. Additionally, everyone will receive a copy of the slide deck here, so no need to try to capture the screen as you're looking at the slides. I will send that slide deck to you and to all those who registered. We're also recording this presentation, and I'll send you a link to the recording after the presentation is complete. That email will come out with the links and the slides tomorrow. Also, just want to draw your attention to the ability to ask questions through the Q&A. The chat feature has been disabled for the webinar, but you should be able to ask questions through Q&A, so find that on your Zoom menu on the screen. Let's jump into the presentation. First off, I'd like to just let you all know that we will be at Intersolar, and if you're interested in going to Intersolar in San Diego, we can get you in with a free booth pass. So there's a QR code on your screen. Again, you'll get a copy of these slides. If you scan that QR code, we can get you a floor pass for Intersolar on the house. So if you're interested in seeing our booth and other booths at Intersolar, this might be of use to you. That's the end of the month here in San Diego. Additionally, we will be in Reno, Nevada at the NABCEP Continuing Education Conference. This is my personal favorite conference annually, just because it's entirely focused on learning. And I always learn a lot at the NABCEP conference. So if you are going to either of those, please look us up. We'll be at booth 413 at NABCEP. But it's mostly courses that we're going to be offering there. So we'll offer a couple of different courses. I will be teaching a course on generator integrations at NABCEP. Also, I thought it would be fun to include this slide on some history. Briggs and Stratton has long been in the battery and engine business. It's a 115-year-old company. So Briggs and Stratton has been around for a long time, and batteries are not a new thing to us. In fact, many of you might not know this, but Briggs and Stratton produced a hybrid electric vehicle in 1973. This vehicle was featured on Jay Leno's Garage at a show that I watched fairly recently, and you can check that out on YouTube if you're interested in knowing. Fun fact about that car. Dual rear axles, because those were lead acid batteries back in the 70s. We've produced electric lawnmowers, electric packs for the film and battery industry. Through Simplify Power, we have mobile deployments with the military and have done a decent amount of testing with the U.S. military for battery products as they transitioned from heavy lead acid systems to LFP. We were heavily involved. We also have a whole line of mobile products. Our Vanguard batteries are quite popular throughout the world and offer rental equipment and other things like golf carts and mobile equipment, lighter weight batteries. We have the Amplify battery out. It's a closed loop communicating battery. And then swappable batteries as well through the Vanguard platform. And then in 2024, this past year, just about a year ago, we released the stackable 6.6 battery, which we'll be featuring today. So just thought it'd be fun to show a little bit of the history that's led up to where we are today. So the stackable battery that we're going to feature today, we do have a partnership with Solarc, and we offer this inverter paired with this stackable battery. Most popular installation for us is a stack of these batteries in a Solarc 15K, although we see a lot of dual stacks together with 15Ks and even as many as 6 stacks. So we're pleased to offer that together with Solarc for whole home backup. So as we get into environmental considerations, what we mean by this for the most part is temperature, but there are other environmental considerations as well. So let's start to talk about temperature. And there are some effects that I'm going to get into on batteries due to temperature, mostly on the charging side. But when we get cold temperatures throughout the country during the daytime, typically these home batteries are paired with solar systems, and solar systems generally charge batteries if there's excess sun available. And in colder temperatures, the charging rates can be restricted with our batteries, and there are reasons for that, which we are going to get into. So I'm not sure where you are. I am in California here. This is a map of temperatures today. It's about 50 degrees. My shop is probably 55. I don't heat it. So I'm wearing a jacket, but I realize that's probably not cold to a lot of our customers that are in cold places. I am originally from fairly close to Buffalo, New York, up here where it did get cold. I prefer to stay in warmer weather, as do batteries. So let's talk about why that is. So again, feel free as we go through this presentation, if you have questions, you would like me to clarify something, to use the Q&A. I will try to answer those questions as they come in. So first off, lithium-ion battery chemistry and form factor. There are a number of different types of cells that can be made from lithium ions, but essentially they're quite similar. They're made by sandwiching a porous separator layer with electrolyte between two different metal contacts, and those metal contacts on the positive side, we have an aluminum foil layer, which is just really spray cast onto a plastic separator. And then on the other side, we have another contact. It's a copper foil contact, and we have graphite cast onto that. So the type of battery we are going to be talking about today is an LFP battery, which is where that metal oxide layer is. It's lithium iron phosphate, technically, on the cathode side. So the reason I'm showing you all this chemistry is to kind of give you an idea of what happens inside a battery cell. So what happens between the graphite negative anode layer and the cathode positive layer is that there's this sea of lithium ions that can transport charge and energy effectively between the metal oxide layer and the graphite layer. And the lithium ions prefer to be in the metal oxide layer. There's an energy preference for them to be there, which is essentially given by the voltage of that cell, or indicated by the voltage of that cell. So the lithium ions prefer to be in this metal oxide layer, and so when you have a discharged battery, the lithium ions are over here. Well, the porous separator layer, it separates the metal oxide layer from the graphite layer, and the lithium is free to move through this separator layer, but electrons cannot. And so when we charge up a battery, essentially we're pumping electrons from the metal oxide layer over onto the graphite anode side. And what that does is it removes electrons from the lithium metal that is kind of embedded inside this metal oxide layer, and that turns those lithium atoms into lithium ions, which then can move through the separator layer to meet the electrons on the graphite side. And the reason I'm showing this is in cold temperatures, those lithium ions can build up outside the graphite layer and are slow to move into the graphite. This is a process called intercalation, and there are reasons why they're slow to move in. Essentially, they're moving into the gaps between the graphite layers. And additionally, the electrolyte itself at cold temperatures becomes more viscous. So for this reason, if you're trying to charge a battery or use a battery in low temperatures, the electrolyte is going to be much slower at transporting the ions, which makes the power output of the battery greatly reduced. It also reduces the efficiency of the battery. And so we need to consider this when we're charging batteries for the safety of the battery. And so if you've used some of our communicating batteries, you'll notice that at especially low temperatures, the batteries might slow down the charging rate that they're requesting from the charge controlling equipment, like the inverter. So for instance, if you had one of our batteries paired together with maybe a Solarc 15K and you've got excess solar and you're trying to charge those batteries in extremely cold temperatures, you might note that your charging rate is slower than normal, and you're feeding more of that energy maybe back to the grid. So we're going to talk a little bit about what happens. We're also going to talk about why we're slowing down the charging rate. Why is it dangerous to charge quickly in cold temperatures? So during charging, as I mentioned before, we're kind of pumping the electrons from the cathode layer over to the anode layer. That frees up lithium metal to become lithium ions. And that ion is inside this kind of liquid gel, which we call electrolyte. And electrolyte is what makes the lithium soluble. It makes ions soluble, just like water can dissolve salt. This liquid electrolyte is not water. It's an organic electrolyte, but it becomes more viscous, just like you consider like honey or molasses getting viscous. And so in cold temperatures, lithium moves more slowly, and it also has trouble getting embedded in the graphite layers. And so it might build up on the front surface of the graphite layer. And so if large amounts of lithium are building up outside the graphite layer, but they're getting access to electrons, they can start to form solid lithium deposits. Now, lithium does not grow as just a nice flat solid. It grows kind of like icicles. And the word dendrite is a term which means dendrite means branches. And essentially, we can get this dendritic growth that can start to plate. So you can get solid lithium plating on the graphite layer at low temperatures. So for this reason, we design our batteries in a way that they can slow down their charging rates. They can request slower charging rates from the equipment in cold temperatures. Let me see, I'm not getting the Q&A to show up on my screen, so I don't see any questions yet. So let's go ahead and keep moving. So this is a graph of a real LFP cell. In fact, it's the same cell shown multiple times. And what we've done, one of my students did this at the local university here where I used to teach. And so what she did was took a cell and discharged it. So started with a fully charged cell and discharged it in different temperatures. When you are discharging a cell, the cell has some internal resistance, right? And that has to do with the flow of the lithium ions through the electrolyte. So at colder temperatures, the electrolyte is a lot less viscous, and more of the energy that that the battery has stored goes into kind of pushing those lithium ions through the electrolyte. And so if we're discharging at the same rate at colder and colder temperatures, you will see that the voltage output of the cell drops, and that's due to some internal resistance. So we can model it, electrically with the figure that's in the bottom left of the screen. So if we can show like an internal resistance to the interior of the cell. So if current is flowing through that cell, you'll lose some voltage across this resistor. How much? Well, delta V equals IR, right? So at colder temperatures, the value of the resistance goes up, and your cell becomes less efficient. And you could actually calculate how inefficient your cell is, or how much efficiency loss there is with your cell, by looking at the voltage drop between these curves. So lithium cells are highly efficient cells, but as the temperature goes down, they drop greatly in efficiency. And so when asked, what is the efficiency of a lithium cell, it's typically around 99%. But if you're discharging at high rates at cold temperatures, that efficiency can drop, and more of the energy that's stored in the cell goes into heating the cell. In fact, for my student, it was very difficult to keep the cells at a fixed temperature. So these cells were inside an oil bath, which was stirred at cold temperatures. And at cold temperatures, that caused the the cost of the cell to start heating, right? Because it's inefficient. So there's heat generated inside the cell, which warms the cell up. So we did our best to keep the cells at cold temperatures throughout the entire curve. Well, we could actually utilize this effect, right? So if we start charging our batteries slowly at low temperatures, we can allow them to we can allow the cell to warm up slowly, and as the cell warms up slowly, it gains in efficiency, and then we can charge it faster without damaging it. So we don't do that with our kind of less sophisticated, our basic battery, the 5 battery. So if you live in a location like I do in California, you don't really need to worry about those types of low temperatures. But if you're in an elevated location, like in the mountains, in the Sierras, or if you're in a colder location across the US, you might want to consider spending a little bit of extra money to getting a communicating battery like an Amplify battery, which can talk to the charge controlling equipment and ask the charge controlling equipment to charge, discharge at different rates. And this allows us to use a kind of a sophisticated algorithm to warm the battery up and keep the battery safe. And for this reason, we offer a 15-year warranty on this Amplify battery that we can also integrate heaters into both of these batteries. But that is a special order item. So if you're interested in heated batteries, we'll get to that shortly. Graham asks, your BMS will control charge rates, i.e. closed loop communications with an inverter. It will dictate what rate it can accept based on temperature. If not using closed loop, would the BMS simply not allow any charging below 0 degrees Celsius? Yeah, that's a great question. Yes, so the BMS on the Amplify battery, if it's being charged too quickly below 0 degrees Celsius, will actually open the contactor and prevent charging. So good question, Graham. I'll get to it here in a bit. I'm about to show some rates of requested charging, and if we exceed those rates, the battery will open up a contactor to protect itself. So good question. All right, so let's look at those charging rates, and I'm going to show you what we've done with our other battery first. So the newer battery that we've come out with, the Simplify 6.6, we've actually changed the electrolyte in this battery to make it less viscous at lower temperatures. And the electrolyte change in this battery allows us to charge this battery all the way down to 14 degrees Fahrenheit. So you'll notice with this battery between 32, so most batteries, most lithium batteries, especially those from our competition, just cut off charging, as Graham hinted to, below 32 degrees Fahrenheit. Well, with this battery, we can actually charge at still a fairly high rate, a 5-hour charge rate, at down to 14 degrees Fahrenheit. And so that covers most of the temperatures you're going to see when the sun is out, when the batteries begin charging from solar. So from 14 Fahrenheit all the way to 122 degrees Fahrenheit, this battery can safely charge. And between 14 and 32, it charges at a rate of C/5 above, and what that means is a 5-hour charge cycle. Above 32, it charges at a rate of C/2 to allow it to fully go from a 0% state of charge to 100% in 2 hours. So this battery is a little bit different. We did not integrate heaters into it because we did not need to introduce the inefficiency in this battery. In fact, a little bit of increased resistance in the electrolyte will naturally heat up this battery when it's being charged or discharged. Additionally, this battery can discharge all the way from -4 degrees Fahrenheit up to, I believe it's 135 Fahrenheit. And so, Graham, you were asking about this kind of the automatically communicated charge rate. So you do have the ability in charge controlling equipment, and I am showing a Solarc here. And on the screen, you have the ability in many charge controlling equipments to introduce a maximum charge and a maximum discharge rate. And I'm showing the values for the number of 6.6 modules you would use on the right side of the screen over there. And you'll realize that these are very high power batteries. So a single 20 kilowatt hour stack of these batteries can actually output 14 kilowatts of power continuously. A single 6.6 kilowatt hour battery can output 6.6 kilowatts. So very, very high power and can charge at quite quick rates as well. But it is better for the batteries to charge slowly. If we are charging the batteries faster, there is a slight overall reduction in the lifetime that you would expect out of the battery. Let me see, I do believe there's another Q&A. So Fred asks, what conditions cause BMS to shut down, not allowing charging or discharging, and how do you recover batteries functionally in this situation? So one of the things that you would do, Fred, so if you do get a fault, let's suppose that your charge controlling equipment was not communicating properly with the battery and just was trying to charge the battery to fault, and that produces a fault on the battery, which opens up the protecting contactor inside the battery. So let's talk about, let's use, for example, an amplified battery. So if the amplified battery gets a fault from too high charge conditions in cold temperatures, one of the ways you can recover that battery is to reset the BMS. And you do that by de-energizing the entire DC bus. So that just doesn't mean turning one battery off. We have to turn all the batteries off. And then we can turn them back on, and then the battery management computer inside the batteries will all reset. And resetting that allows it to use current conditions and for you to adjust the equipment that might have caused the fault in the first place. There is more information about this, and we'll come to some of that here. And then I have an entire training on the battery management systems. I also encourage you to refer to the battery manuals, but I'm happy to take questions towards the end. So great question. Thank you for asking. Some features of the 6.6 battery. So I mentioned this being a very high power output battery. It's also a stackable battery. So you can do stacks of up to 3 6.6 kilowatt hour modules, getting 20 kilowatt hour stacks. All of the communications for this battery, all of the power are done through these gold-plated connectors that you can see here, the Briggs and Stratton rapid stack connector. And so this allows those batteries to be stacked up without the use of any wires. The only wiring and cabling you will have is on the output of the battery controller. And then there's a controller at the top that integrates the information from all of the battery modules below, monitors all of the cell temperatures, etc. So there's a lot of information being processed in these batteries. They're quite sophisticated batteries, and these are the ones that can operate in colder temperatures. Even so, if you're in a very cold place, we see a lot of our batteries installed in Alaska, Canada, places where it is extremely cold. We would encourage you to install them in an indoor location. Even if it's not a heated location, you'll get moderation in temperature between daytime and nighttime and more of an average if you're installed indoors. This particular battery will do about 6,000 cycles at a 0.5 charge rate, even at 100% depth of discharge. So you'll get elevated numbers of cycles by reducing your depth of discharge a bit and reducing your charge and discharge rates. But still, even in the lab with high charge and discharge rates, you're looking at cycles of 6,000 plus. And if you're in a location where you're typically charging once, with the sun coming out during the day, discharging during the nighttime, if you did one cycle per day, you're looking at 16 plus years of lifetime out of these batteries. The 6.6 battery is outdoor rated, so it's the IP65 enclosure. And can be mounted on the floor or the wall. So it's a pretty versatile battery. Some of the other batteries, the Phi and Amplifies, are not outdoor rated, but we have solutions for if you do want to mount them outdoors. And we also have some heating solutions, which I'm going to get into shortly. So we mentioned cold temperatures being hard on batteries in terms of it increases the internal resistance, makes the battery less efficient. And if charged very rapidly in cold temperatures, it can potentially reduce the life cycle of the battery due to that dendritic growth. In fact, the dendritic growth can get so bad that it could puncture the separator layer inside cells if you charge rapidly in cold temperatures consistently. And so I'm showing an installation here. I mean, this is in Alaska. 907 is that area code for Alaska. 907 Solar does a lot of simplified batteries. Notice how the tilt of these solar panels is tilted far from level towards the south. These panels are facing south because the sun is quite low in the sky in Alaska this time of year. Also notice that behind us is a shed which houses the batteries, and mention again that this kind of cover for the batteries helps to reduce those kind of spikes in cold temperature. Fred asks, aside from Solarc, what other inverters are compatible with Phi batteries? So Fred, we will be announcing that list fairly soon. We have a large number of inverters that have gone through testing with us, and we'll be announcing those soon. So I think I should hold off on answering that question until we have the marketing material ready. So I appreciate the question. If you would like to know a specific inverter, you could reach out to me at the email address and I'll reply after the talk. External temperature conditions, amplified charge rate is actually based on the internal battery temperatures. But based on the internal battery temperatures that are monitored by the thermistors inside the battery, the rates of charge vary. And so from 15 to 25 degrees Celsius, the battery requests 30 amps of charging maximum. From 7 to 15 amps. From 0 to 7, it will reduce to 7 amps. From -10 to 0 Celsius, 3 amps. And at -20 Celsius, I believe that's -4 Fahrenheit, it charges at just a rate of 1 amp. So slow charging, but there's a decent amount of internal resistance there. And that slowly charging, trickle charging the battery at a low temperature can result in internal heating, which can raise the temperature of the battery. And so you can start at slow amperages and move up as the battery starts to warm up. If you have an electric vehicle and you've charged in cold temperatures before, you'll note that the battery tries to precondition itself. So as I mentioned, this Phi battery, it does not have closed loop communications, so it will not be able to communicate to charge controller and equipment. So you would need to have external equipment that can adjust the charge rate for this battery. It's also not an outdoor rated battery. It's great for locations like mine. But you would want to have charge controlling equipment that can manage temperature, and you can put temperature sensors on these batteries. You can also integrate heaters on both the Phi and the Amplify battery, so I'm going to explain that in just a second. The Amplify battery, as I mentioned, has more sophisticated algorithms for charge rates. And there are 2 layers of protection in here. There's the internal BMS, and then there's a contactor in here as well. And then as well as those two, the physical connections inside the battery, there's also the closed loop communications, which tell the inverters or the charge controllers what rate the battery wants to be tested at. So for instance, if you're operating the Amplify battery with SMA inverters, so Fred, you asked apart from Solarc, so SMA is one of them. We have a list of, I think, 4 or 5 others that are coming out soon. The charge rate of the Amplify batteries would be communicated to SMA. Shown with Solarc here again, but you're looking at these outdoor rated NEMA 3R enclosures. So if you want to use a Fire and Amplify battery outdoors, we would encourage you to use a Fire and Amplify cabinet. You might, of course, consider different cabinets or enclosures, and they exist. These Boss 6 and Boss 12 cabinets are manufactured in the US, here in California, just like the Phi and the Amplify battery. And so if you are in California, these do qualify for SGIP rebates, which is a 30% off rebate, I believe, although there's some paperwork associated with it, and I know getting those rebates from the government can be slow. There are other considerations as well. So if you're in a consistently cold place and you want to retain some of the battery temperature, simply isolating the battery from thermal contact with shelves, like if you have a battery sitting on a metal shelf, simply putting some insulation underneath that battery can reduce the thermal contact. Air is actually a fairly poor conductor of heat. And so just simply reducing thermal contact reduces the flow of heat out of the battery due to due to contact. There's also, of course, contact with the air, but you can add some insulation in the cabinets. If you have a battery together with an inverter, keeping the inverter in the same enclosure as the battery can also retain some of the inefficiency from the inverter, and that heat generated can keep the batteries warmer. So that's one of the nice things about the cabinet on the right, that access cabinet, is the inverter's heat can be retained. There are temperature controlled fans inside that cabinet. So if it's the summertime and it gets too hot, the circulation fans will come on and remove that heat from the enclosure. There are a lot of nice things about those enclosures. Additionally, we can integrate heaters directly into the batteries themselves. So we do have a 75-watt heater that will go directly communicate with thermistors inside the battery and turn on and off based on the battery temperature. And there's a setting for that that goes on the control board. But this is a special order item. I believe it costs a few $100s extra per battery to get heaters built into them. And so if you have an outdoor battery installation, this might be a nice option for you to be able to introduce heaters. I do mention, though, that heating the battery, because you are locating it outdoors, does make the system a little bit less efficient, right? You are putting heat into the battery, which does leak out into the environment. And so some of your energy is wasted in terms of heating. So using things like insulation can overall save some money, not just in terms of needing the heaters, but needing to use the heaters less frequently. So you could use this temperature control system that we sell, and it's integrated into our enclosures, but you could also insulate as well. So doing both is a good option. And they're heaters that get adhered directly to the backs of the batteries through these heating pads. So there's adhesive that is used. This is an installation that's in Buffalo, New York. I think Buffalo Solar installed this one. These are a number of cabinets. They have integrated heated batteries inside them. And then you have a number of Solarc inverters. I think there are 7 or 8 Solarc 15Ks powering this manufacturing facility outdoors in Buffalo. I haven't mentioned higher temperatures, and batteries generally are fairly efficient at high temperature, and the electrolyte is quite stable at higher temperatures. So you really need to get significantly over 100 degrees before there's kind of any risk to the batteries, and they will charge up to 120 degrees Fahrenheit without issue. But if you are in a desert location, which can get extreme temperatures and sun, it's best to avoid that sun contact directly on the battery enclosure. It's also important that, atmospheric considerations now are outdoor rated batteries like our Simplify 4.9 and the Simplify 6.6 are protected from environmental risks, but moisture can cause problems even to batteries which are stored underneath a roof due to high humidity levels. And so keeping batteries inside a cabinet can reduce the amount of humidity that batteries are exposed to as well. Others that are using batteries, I would not recommend the use of our batteries on yachts and boats, especially if they're going to be in a location where they could get salt spray. You would really want to have a sealed battery for that. Altitude has very little impact on the Phi and Amplify batteries because these include cylindrical cells, and the cylindrical cells are fully sealed, and they're also just naturally good at it's a good system for maintaining pressure. So at high elevations, there's low external pressure, but these cylindrical cells do not have a limitation. There is a limitation on some of our equipment, and you need to make sure that some of your other equipment, like your inverter, etc., doesn't need to get derated. So, for instance, if we take our generators up to high elevation, there is going to be some derating on the power output of the generator based on the lower cooling ability of the equipment because there's less overall density to the air. And so check your elevations, check the battery manuals, the inverter manuals to make sure that they're able to function at high elevations. Additionally, if you're installing in locations where there's lots of vibration, I would advise against, putting batteries in direct contact with frames. So if you are going to install batteries inside an RV, for instance, I would encourage the use of a layer of foam underneath the batteries to absorb some of that shock, so that if you hit a big bump, it doesn't directly impact the mass of the battery and potentially cause damage due to those jolts. We do a significant amount of testing on our batteries. We have a testing facility in Oxnard, California, that's being shown on the screen there. And Briggs & Stratton continues to develop and deploy in-house and external testing. So there's a lot of testing, cycling that happens with our batteries. We also are very stringent in getting UL certifications, going through testing that I know with some of these lower cost batteries that are coming in doesn't always happen. Right, so we have UL 9540, 9540A, 1973, 1642 on our batteries, our modules, our cells, etc. I'll explain slightly what those tests are. We're also one of the first companies that have gone through edition 3 of the UL 9540, which allows our batteries to be paired with any 9540 compatible inverter. So an inverter that has their own 1741 SB can be paired with our batteries, and we've met those UL test regulations. So UN 38.3 has to do with shipping of batteries, and so our batteries are some of the few batteries that can be certified to ship. This involves air shipments involve limitations overall based on weight, and obviously batteries that are going through air shipments go through a low pressure. And so if you have batteries that are not rated for elevation, they would not be suitable for air shipment. Well, our cylindrical cells in the Phi and the Amplify batteries can tolerate low pressures just fine. These tests involve thermal cycling of the batteries, low pressures, high pressures, vibration, so intense vibration to simulate turbulence, and then shock. There are even drop tests that occur with these batteries. And you need to pass all of these tests in order to get UN 38.3. I believe there's a typo there. I do believe it is UN 38.3. But we have that for some of our batteries, not all, because our bigger 6.6 batteries do not meet the weight limitations. They're 140 pounds each, and I do believe the weight limitation is 90 pounds. So these conditions, they overcharge the batteries, they even short circuit batteries to cause contactors to open up. UL certifications are what most batteries that are going to go on home systems need to go through in the US. So UL 1642 is a certification based on cell safety. All battery cells need to go through this, and it involves similar tests that involve shocking, vibration, dropping, heating, temperature cycling, low pressure, short circuits, etc. And it verifies the safety of these cells. So essentially taking the cells through abuse. Once those cells are approved with UL 1642, the cells get assembled into batteries, and those batteries are then tested to get UL 1973, which is a module level safety test. And this ensures that things like the overcurrent protection, the overvoltage, the BMS safety features are intact. These Phi and Amplify batteries come with an enclosed circuit breaker in them as well, and so trying overcurrent protection, etc., with the batteries gets tested in UL 1973. UL 9540 is a system level test. So if I had, let's say, 6 of the Phi battery modules, or 6 of the 6.6 modules, the system level safety test is a UL 9540. Those 6.6 batteries, the Amplify batteries, have all gone through system level testing. And so we have the battery cabinet shown there is certified to hold the Phi and the Amplify batteries at elevated overall capacities. I believe that's a 46 kilowatt hour bank. So it's not restricted to the 20 kilowatt hour bank in many locations where UL 9540A testing takes precedence. And also because of the DC ESS certification on the 6.6, that can be used with any 1741SB inverter. So the 9540A test is not a certification. It's a testing method that informs the 9540 certifications. And that testing procedure is laid out here. Essentially, what we do is we look at the cell level tests, and if the cells are inherently safe and have no risk at all of burning, which could be the case if you had a cell that was not a lithium, but all of the lithium-based cells, ours and all of our competitions, have electrolyte inside them, and that electrolyte is a flammable liquid, so if you puncture a cell, it could burn. Then there's a module level test if the cell does not meet very strict conditions, which lithium cells will not. Then the module level test tests all the safety equipment that's integrated into the battery module itself. Once that has proved safe, you can move on to the unit level test. Unit level test, it might be a whole system level test. And if you don't meet the unit level test, you might have to do a site-specific installation level test. And so for very specific systems or larger systems, you might have to integrate fire protection equipment, etc. And this safety is important, as makes evident in this Moss Landing fire recently and other fires that are out there. We certainly should be thinking about safety when we're installing energy storage systems. I know many times the customer wants the lowest cost system that can be purchased that stores the most amount of energy, but when you think of some of the risks that are involved, it might be better or more advantageous to go with a system or a company that has kind of the history that we do with safety testing our LFP batteries. Briggs and Stratton, through Simplify, has been making LFP batteries safely for the film industry, for home energy storage, for the off-grid industry since 2010. So we've got a lot of history doing this. We've done it as well for the military, and so we have very heavily safety tested batteries that are on the market. Additionally, we offer a whole line of generators. So there's a whole history of Briggs and Stratton engines used for power generation all the way back into the 1950s when Generac was first getting started and employing Briggs and Stratton to manufacture the engines for them. We manufacture generators and have been doing so for a long time. We're showing on the screen the PowerProtect 13K, the 18, the 22, and the 26K, which is the most powerful air-cooled generator on the market right now for whole home backup, is the Briggs & Stratton 26K generator. And then I'm also showing our transfer switch on the screen there. That transfer switch allows smart home load management based on power draw of equipment. And so it can turn on and off equipment like a water heater or like maybe a hot tub based on conditions of power draw and programming. If you're interested in learning more about our generators, our batteries, and encourage you to sign up for a free Power Academy course, free Power Academy account, which can give you access to in-person and self-paced learning online through our Power Academy. Also, want to highlight, the stackable nature of this 6.6 battery. If you've not done your first 6.6 ESS system, you are eligible as an installer, a licensed installer, for a $1,000 rebate off your first installation. Additionally, you can get and I'm going to mention it in a few minutes, you can get $100 off. Every quarter we process rebates, $100 off each battery module that you install. So if you do a system with 6 battery modules for a customer, you'll get a rebate for $600 at the end of each quarter, or at the end of the quarter. Also, to try to make things easier, we have put together some packages with this with the Solarc offerings that I mentioned earlier. These packages let customers know answers to kind of frequent questions like how much backup time am I expecting to get, etc. And so we're showing a pairing there on the left side with a Solarc 8K. That's one of the smaller inverters. a 6.6 kilowatt hour battery there. This is a smaller package, but it's good to back up just the essential loads in the house. We're assuming that they would back up 50% of the home, and that battery would then last about 11 hours of backup for the typical home if you backed up half the loads. If we went with a Solarc 12K system and 2 of the 6.6 modules, you get more like 14.5 hours of backup, where you're actually backing up 75% of the home. So we don't get double the backup time because we're going to back up more loads in the house now, but we might not back up the air conditioner or the water heater, things like that. And then whole home backup is probably the most common thing that we're seeing now. It does make the installation a little bit easier because you don't need to install a critical loads panel, but you could install a sub panel that operates off the smart load feature of the Solarc. Up to 80 amps can be dropped off based on battery percentage. That's whole home backup with the Solarc 15K. We're showing just with a single stack of batteries there, but many customers are choosing to install multiple 20 kilowatt hour stacks. And for each individual module that you add, you get a little over 5 hours of backup time. So it's quite an easy system to install as well. So I mentioned, if you have not installed one of these, we are offering $1,000 off for your first ESS system. Somebody also asked, is there a three-phase solution as well for commercial? Yes, I debated putting those slides in today. I wasn't sure how much time we would have. We do offer high voltage battery modules and paired with different options for three-phase inverters. I think the most common three-phase inverter that our high voltage team uses is the Oztech inverter. So they make a 30K inverter that we pair together with Nuvation equipment. And yes, we have three-phase solutions. So you can also do three-phase power with any of these inverters that you see on the screen there. In fact, I'm running the 15K in my shop right now with three of those batteries and running three-phase 208. So 208 leg to leg, three-phase 120 degrees between those phases. There are also, you cannot do 480 three-phase with a 15K, but Solarc also makes a 30K inverter, which you can integrate solar and have three-phase 208, and then they make a 60K inverter that our high voltage batteries will work with, that'll do native 380 or native 480, excuse me. So 277, 480. So yes, we do have three-phase options. High voltage batteries, our batteries go all the way up to 1200 volts. If you're interested in that, please reach out to us. So thank you for that question. And then Fred asks, I'm planning to use Amplify batteries. Let me get it on screen here. I'm planning to use Amplify batteries in 5 to 15 different project site locations. What platform is your best recommendation to monitor all of the plant's performance at the same time? I would recommend using our Energy Track platform. So we make our own gateway, and actually we'll be coming out with a new one soon. We make our own gateways, and this Energy Track allows you to monitor all your different sites. You would need one gateway per installation location. So even if you had 70 batteries, or let's say 50 batteries at a single site, you just need one Energy Track gateway to monitor all of those batteries. And so I recommend our Energy Track platform. If you choose to use Solarc's equipment allows you to monitor at a bank level, so it doesn't give you individual battery temperature and charge, discharge, and health information like our Energy Track platform does. But you can do some monitoring through the Solarc app of your battery bank. And then New Sun Road also makes a platform for us as well for monitoring our batteries. So we actually have a few minutes left. If there are more questions, I'll encourage you to put them into the chat. But before we take questions, let me just say, if you are interested in getting the NABCEP continuing education credits for this course, please send me an email, energystoragetraining@basco.com, energystoragetraining@basco.com, and myself or one of the other trainers will get you your certificate issued. When you send that email, do let us know how your name should appear on your NABCEP certificate so we get it right. So simple email can just say credits, please, and then my name should appear as. So send that email to me. I'll check the attendance logs and issue your credit. If there are no more questions, that we will go ahead and close the webinar a few minutes early. If you have questions about designing a system, you're welcome to email our trainers. You're also welcome to contact our application engineers. So we have sales application engineers that can help design systems, including high voltage. We have a team that does high voltage systems. So if you're interested in commercial type applications, reach out to my email, ask to be put in contact with our commercial team, and we can help you generate quotes and design your system. The same for residential systems. We're happy to help. So it doesn't appear that there are more questions. I thank you for your time and attendance. And we're going to go ahead and close the webinar. So thank you, everyone.